This video is on quadratic models. A quadratic model has the form of y equals ax squared plus bx plus c. The shape of a quadratic is called a parabola, and it has many important features that you need to know. So here we have a diagram of a quadratic with the important points labelled. So first of all is the y-intercept, which is at 0c. So in the equation, that c is the constant that's added to the end. I'm just going to circle that in red right now. So that value there is the y-intercept. X-intercepts are the roots or the zeros of the equation, so where the graph crosses the x-axis. Axis of symmetry has the equation x equals negative b over 2a. So as you can see there, it is the line that chops the graph in half, and it is the x-coordinate of that line at the vertex here that I have just circled. The vertex or turning point is halfway between the x-intercepts, and the axis of symmetry is the x-coordinate of the vertex. Now once again, just to go back to with the axis of symmetry, you have to write the equation x equals. You can't just write the x value, you have to write x equals and whatever that value is. So our first example, find a quadratic model that goes to the points 1, 9, 2, 18 and 3, 31. So when we have something like this, we're going to create a series of equations, one for each point. So if we start with the point 1, 9, we're going to make an equation for that. So remember, in this one, x would equal 1 and y would equal 9, and we're going to use the equation y equals ax squared plus bx plus c, and we're going to sub x and y in. So the first equation would be 9 equals a times 1 squared plus b times 1 plus c, which just gives us 9 equals a plus b plus c. And we're going to do that for each of the points. So our next point is 2, 18. So when x equals 2 and y equals 18, and we're going to create our equation now. 18 equals a times 2 squared plus b times 2 plus c. Simplify that, so it'll be 18 equals 4a plus 2b plus c. And then the last point, as you can see now we've got three equations and they are all linear because there's no squareds with our variables, which means we can use our simultaneous equation solver on our calculator. And I'll go to that now to show you how to do that. So on our calculator, we just need to go to Menu, number 3, Algebra, and then number 2, Solve System of Linear Equations. Number of equations that we've got, which is 3, because we've got an a, b and a c to find. And then in our variables, you can leave it as x, y, z and change a, b and c, or you can change these to a, b and c yourself. Now we just put in the three equations that we had. So we had 9 equals a plus b plus c. Our second equation was 18 equals 4a plus 2b plus c. And our third equation, 31 equals 9a plus 3b plus c. Once you've got them all entered, just press enter and it will tell you our values of a, b and c in that order. So you see here a, b, c, and that's the order of the solution. So a is 2, b is 3 and c equals 4. So from our calculator, we've got the values of a equals 2, b equals 3 and c equals 4, which means we can then put those into our equation. So it'll be y equals 2x squared plus 3x plus 4. Example 2. A quadratic model has the following properties. The axis of symmetry of y equals fx is at x equals 4. The y-intercept is at 0, 12. The curve passes through 1, 5. Find the roots of f of x equals 0, and then we want to find the minimum value the model takes. So we're going to start with the first point here of the axis of symmetry of y equals fx is at x equals 4. So that just means our axis of symmetry is at x equals 4. We have an equation for that, which is negative b over 2a equals x, our axis of symmetry. We know that that is 4, so negative b over 2a must equal 4. Next information that we can use is the second point. The y-intercept is at 0, 12, which therefore means that c has to equal 12 because that's our y-intercept. Then we've also been given 1 point, which is 1, 5, so we can create the equation with that information. 5 equals a times 1 squared plus b times 1 plus c, which is 12. And then we can simplify this. So we've got 5 equals a plus b plus 12, which means then we get negative 7 will equal a plus b. Now from here, we now have two variables we need to solve for, a and b, and we have two equations, which is what we need. We just need to use our GDC to solve. To do this with a simultaneous equation solver, we need the first one here to not be as a fraction, so we can change that to negative b equals 8a, so multiply the 2a to the other side. We can then put that into our calculator and we will find that a equals 1 and b equals negative 8. So now we can use this information to write an equation for this graph, which would be y equals x squared minus 8x plus 12. And then we can use our graphics calculator once again to solve this. So when this equals 0, so we can find the roots, because remember, to find the roots in an equation, we make the quadratic equal 0. If we do that in our quadratic solver, you will find that x equals 2 or 6. We're going to have the two solutions. B, find the minimum value the model takes. So if we were to graph this, you will find that the graph is a happy face. So it looks like this. And that's because our x squared in our function, I'm just putting a box around it before, is positive. So when we want to find the minimum value, I'm wanting to find the y coordinate of the bottom of this graph. Now we were told in the question the axis of symmetry, which I'm going to put the dot line there, is when x equals 4. We know the x value at the minimum, which means we can just put that into our equation to find what the minimum value is. So y equals 4 squared minus 8 times 4 plus 12, and what you'll find that equals negative 4. So the minimum value this model takes is negative 4. Final example, example 3. Suppose that the height h in meters of a projectile above the ground at time t seconds after its launch is given by the quadratic function ht equals 2.25 plus 6.55t minus 1.75t squared. From what height was the projectile launched? So from here, what height was the projectile launched? So there's many different ways you can do this. Put it into your calculator and find that y-intercept. We also know when the projectile was launched, the time was equal to 0. So we could put that into the equation. If we look at this here, if we were to put t equals 0 into this, these first two parts here will cancel out because they're both going to be times by 0, which means the height when the projectile launched was just 2.25 meters, which we can get straight from the question there. Part B, what is the maximum height reached by the projectile? So we're going to go to our calculator for this and we're going to graph it and look for the maximum. And we are going to graph this quadratic, so 2.25 plus 6.55. Remember, x instead of t we have to put in our calculator, minus 1.75x squared. Now in this one we want to look for the maximum. We want to know the maximum height reached. We can't see the maximum here, but our calculator will still find it for us. So if you go menu, analyze graph maximum, we know it's going to be between this section, so we can just go either side of that and it'll zoom out for us itself and show us the maximum. So the maximum height is 8.378. So remember the x coordinate is the time and the y coordinate is the height. So for this answer we are wanting the 8.38 to 3 significant figures. And as we found from our calculator, the maximum was at 8.38 meters. Part C, at what time will the projectile be at its initial height again? So how long will it take for it to get to 2.25 meters again? Let's go to the calculator and I'll show you how you can work this out. Okay, to find out what time the projectile will be at its initial height again, we know that's 2.25 meters. So we can graph another graph that's just 2.25, and it will draw a horizontal line straight across. And let me just zoom in slightly here. So we can see the initial here, where we started, that's where the projectile started. Now we want to know what is the other intersection point. So we go menu, in intersection, and we want to know how long it's taken to get to 2.25 meters again, which will be our x value, so 3.74 seconds. All right, and as we just found then, it will take 3.74 seconds after it's launched to get back to 2.25 meters. And part D, at what time after launch does a projectile reach ground level? So that it means we're looking for the x-intercept, the 0, the root of the equation, whichever one you would like to look at. So let's go back to our calculator to find that out. Now to find out when it reaches the ground level, we are wanting to find the x-intercept. So we can go menu, analyze graph. Remember that is the 0. Now here it says which graph. So it wants to know which graph we are looking at. So we just have to select the blue graph, and it knows that's the one we're looking at. Highlight our intercept, and you can see there it is 4.06 to 3 significant figures. And as we just found, it was at 4.06 seconds. And that's the end of this video.